Chapter 3, Day 9. Learning target. I will be able to solve linear programming problems. So based on Day 8 information, we're going to extend the information to try to maximize or minimize the scenario based on the given constraints. So let's take a look at this example today. A manufacturer produces two models of snowboards. The amount of time required to assemble and package Model A. So there are two requirements, two things that needs to get the Model A done. They have to assemble it and they have to package it. So two things. Model A requires 4 hours and 1 hour respectively. For Model B, assembly takes 2 hours and packaging takes 1 hour. So same for Model B. Assembly takes 2 hours and packaging takes 1 hour. There are 16 hours available for assembly and 6 hours for packaging. So it's limited by, so each day they can only assemble up to 16 hours, no matter it's Model A or Model B. And they can package for 6 hours, again, between Model A and Model B. The profit per unit for Model A is $50 and for Model B is $30. Find the solution, find the number of each snowboard that should be produced each day to maximize the company's profits. So again, I mentioned that the clue comes from what you are looking for, and most of the time it lands on the very last sentences. Find the number of each snowboard that should be produced. So number of snowboard. So let's name number of Model A as X, number of Model B as Y. So for each day, they assemble number of Model A as X, number of Model B as Y. And what do we know? According to the story given, we know at this they cannot assemble negative boards, right? So the first constraint we can write out would be X greater or equal than 0, Y greater or equal than 0. So these are physical constraints. You cannot build negative ones, so they have to be positive at all time. Next we have, because for the assembly, so first one I want to write the assembly. Do you see the very first row I write assemble? Assemble. So for each Model A, it requires 4 hours. So 4 times X, that would mean the total hour. Assemble Model A. Second one, Model B requires take 2 hours to assemble. So 2 times Y would be the total amount of time spent on assembling Model B, snowboard Model B. And the total, I cannot exceed. The company is not going to spend more than 16 hours assemble the snowboard. So 4x plus 2y would have to be less or equal than 16. How about the package? So we know Model A requires 1 hour of packaging. Model B requires 1 hour of packaging. So 1 times x plus 1 times y. And the total amount for packaging is only 6 hours. So they can package up to 6 hours. So x plus y is limited by 6 hours. X plus y is less or equal than 6. And we know the profit is going to be 50 for A, 50 times X. We don't know how many snowboard they build for Model A. And then 30 times Y. So we want to find the maximum profit equations. Now we have the constraints. Can we go ahead and mark down the feasible regions? First, x greater or equal than 0. X greater or equal than 0, that's our y-axis. And then it's going to mark on to the right-hand side. X greater or equal than 0. Second one, we have y greater or equal than 0. And that's our x-axis. Greater or equal than 0, so it should be marked as greater or equal than 0. And this time, as you can see, we are limited to first quadrant again, followed by 4x plus 2y less or equal than 16. So this is in standard form. Maybe I should use the x-intercept, y-intercept. That would be easier. So when x equals 0, y is 8. When x equals 0, y is 8. So 1, 2, 3, 4, 5, 6, 7, 8. When y equals 0, x is 4. So 1, 2, 3, 4. So this is going to mark as 4x plus 2y equals 0. And it's less or equal than 16. So should I shade it above the line or below the line? So you can see 0 plus 0 is less or equal than 16. So I have to mark in the region that has the 0, 0 in it. I have to mark down the region that has the 0, 0 in it, which is below the line. And the last one, we have x plus y less or equal than 6. X plus y less or equal than 6. So the x-intercept is going to be 6. The y-intercept is going to be 6 as well. So our line looks like this. So again, my line may not be drawn to scale. It's not really straight. When you do your work, it should be pretty straight. X plus y less or equal than 6. So if we plug it in the test point, 0, 0 again, 0 is indeed less or equal than 6. So where should we mark it? It should be the region that contains the 0, 0 in it. So do you see which one is being shaded? Which region is being shaded 4 times, all 4 times? So go ahead and mark down the region that's being shaded all 4 times. And then we are going to follow what we did in day 8. Find the vertex to help us categorize the profit equations. So what's going to be our vertex? So as you can see, we have 0, 0. So that's first one, the point of origin, followed by this point. This is the x-intercept for 4x plus 2y less or equal than 16. So which is 4, 0. And then this is going to be the y-intercept for x plus y equals 0, which is 0, 6. And then this point, I would have to use the calculation. So between 4x plus 2y equals 16, and then x plus y equals 6. Using the substitution, I know y equals negative x plus 6. So I'm going to plug it into the first equation. 4x plus 2 times negative x plus 6 equals 16, which is 4x minus 2x plus 12 equals 16. So 2x equals, subtract 12 to both sides, so x equals to 2. And that means my y is going to be 4. So this point is going to be 2, 4. So as you look on the graph, my graph doesn't look very accurate. So on your graph, it should look more accurate than mine. Now, we have the profit equation, 50x plus 30y. So I'm going to plug that number in to this profit equation. So P of 0, 0. So obviously, if they are not making any snowboard, 0 for model A, 0 for model B, they are not making any board. How much profit will they make? So 50 times 0, 30 times 0, basically it should be 0. Followed by the second one, we have 4, 0. So if they make model A 4 units, if they make 0 model B, how much would they make? So 50 times 4 plus 30 times 0, equals 200, followed by P of 0, 6. So this time if they make 0 model A and then 6, so they spend all the time making model B, how much would they make? So 50 times 0 plus 30 times 6, so that's 120. 180, I'm sorry, 30 times 6, that's 180. And then the very last one, we have P of 24. So that's 50 times 2 plus 30 times 4, which is 100 plus 120. And that is 220. So that's the most of them all. So what would be our final answer in words? We calculate, plug it into each of the critical points, and we find when the company makes 2 model A, and 4 model B, they will have the greatest profit of, don't forget to put down its profit, of $220. So based on the labor information given, if you want to maximize a company's profit of this snowboard building company manufacturers, they should spend the time of making 2 model A and 4 model Bs.